Let's say we had this following system of linear equations. 2x minus 3y plus 4z is equal to -1, x plus 2y minus z is equal to 7, and negative 3x minus 2z is equal to 3. Now we know how to manipulate systems of linear equations using row operations, elementary row operations, and turning it into row echelon form, but sometimes it's a little bit of an annoyance to have to write all the plus signs, the minus signs, all of the equal signs. So wouldn't it be nice if there was a simplified way of writing systems of linear equations so that we could easily manipulate them or work with them? Well, there is. We can represent a system of linear equations using something called a matrix. And a matrix is simply just a rectangular array of numbers. So I'm actually going to write this system of linear equations in something called matrix form. So what I'm going to do is I'm going to take the coefficients of all the unknown variables on the left-hand side, as well as the constants on the right-hand side, and put that into our matrix. So starting with the unknown x terms, I'm going to write down 2, 1, and -3. That's because those are the coefficients of all the x terms. Moving on to the y terms, I'm going to write down -3, 2, and 0. -3, 2, and 0 because those are the coefficients of all the y terms. And finally, I'm going to write down all the coefficients of the z terms. 4, -1, and -2. 4, -1, and -2. And for the right-hand side here, I'm going to write down -1, 7, and 3. And I'm going to put these square brackets around this array of numbers. Now this matrix that we just wrote is called an augmented matrix. And the reason it's called an augmented matrix is because it includes all the coefficients of all the unknown terms on the left-hand side of this system of linear equations here, as well as all the constant terms of the system of linear equations here. And whenever I write systems of linear equations in augmented matrix form, I usually like to do this little vertical dashed line here, just so I know that everything on the left of that line is the left-hand side and everything on the right is the right-hand side. Now we can also represent the system of linear equations using something called a coefficient matrix. And the coefficient matrix is simply a matrix of only the left-hand side. So we're only including the coefficients of the unknown variables in this matrix. So really, if we looked at this augmented matrix, the coefficient matrix would just be this matrix right here. So I'm actually going to write that out. The coefficient matrix for this system of linear equations is going to be 2, 1, -3, -3, 2, 0, and 4, -1, -2. And I'm going to put the square brackets around here. Now this matrix right here is called coefficient matrix. And the coefficient matrix only includes the coefficients of the unknown variables, so it doesn't include this right-hand side of all the constants. And this matrix right here is called a 3 by 3 matrix, and that's because it has 3 rows, 1, 2, and 3, as well as 3 columns, 1, 2, and 3. The augmented matrix, which was this matrix right here, is actually a 3 by 4 matrix, and that's because it has 3 rows, 1, 2, and 3, and it has 4 columns, 1, 2, 3, and 4. So when we're trying to determine the size of the matrix, size of any matrix, we simply count the number of rows and count the number of columns, and that gives us our matrix size. So let me scroll down here and we can actually do a few examples of determining the matrix size. So let's say I had a matrix 1, 2, 5, 2, 4, 9. Let's say I had this matrix. Well, this matrix has 2 rows, 1, 2, and it has 3 columns, 1, 2, 3, right? We have 1 row here, we have 1 row here, so that's 2 rows, and then we have 1 column here, 1 column here, and 1 column here. So that's 3 columns. So we say that this is a 2 by 3 matrix. The size of this matrix is 2 by 3. Let's say we had another matrix, 0, 0, 0. Well, this has one row here and one row here. So we have 2 rows. And then we have one column here, one column here. So we have 2 columns. So this matrix right here is a 2 by 2 matrix. The size of this matrix is 2 by 2. Let me scroll down and we'll do a couple other ones. Let's say we had this matrix. We only had one number in it. Well, technically this has one row and one column. One row and one column. So this is a 1 by 1 matrix. And let's do one more. 2, 3, 4, -1, -2, and -3. Well, this is an interesting matrix, right? This has 1, 2, 3, 4, 5, 6 rows. 6 rows, and it has one column. So this would be a 6 by 1 matrix. And just as a note, we always list the row first and then the column. This would not be a 1 by 6 matrix, because that would mean it had only one row and 6 columns. So let me scroll down and we'll talk about one other thing about matrices before we get into the formal definition of a matrix in the next video. Let's say we had this matrix right here. The numbers that are inside of a matrix are called elements, or they're sometimes called entries as well. So every number in this matrix, in this case 16 different numbers, each one of these numbers is called an element of the matrix. So for an example, if I was referring to element 1, 1, that would mean that I am looking at the number in the first row and the first column. So the first row in this matrix is right here, and the first column is right here. So the 1, 1 element of this matrix is 2. What if I was referring to element 2, 1? Well, this refers to the second row and the first column. The second row is right here, and the first column is right here. So that would be this 3 term. So element 2, 1 of this matrix is 3. How about element 3, 3? Well, that element refers to the third row, which is right here, and the third column, which is right here. So the intersection of that row and column is this 0 term right here. So element 3, 3 is 0. How about element 4, 3? Well, this element refers to the fourth row and the third column. So the fourth row is right here. And the third column is this column right here. So the intersection of that row and column is this 4. So I've just cleaned up this matrix a little bit, and we'll do one more example. But before I do, whenever I have a matrix, I sometimes like to write down the row number and the column number on the matrix. So we have row 1, 2, 3, and 4, and we have column 1, 2, 3, and 4. And this makes referring to elements a lot easier. So let me actually do 2 more, just so we understand elements of matrices. If we looked at element 1, 4, this would refer to the row 1 and the column 4. So row 1, column 4 would be this number right here, right? Element 1, 4 is equal to -1. And then finally, let's do element 2, 4. Well, this refers to the second row and the fourth column. So the second row and the fourth column is this element right here. It's 8.